May 27, 1941, 400 miles west of France. The Atlantic Ocean is a chaotic field of white foam and black smoke. The German battleship Bismarck is no longer a strategic threat. It is a floating target absorbing the concentrated fury of the British home fleet. The operational objective has shifted from interception to annihilation. The battleships King George V and Rodney have closed the range to point-blank distance. They are executing a firing solution that involves 2,876 shells. This is not a naval duel. It is an industrial demolition of a 50,300-ton steel fortress. The physics of the engagement have overwhelmed the structural integrity of the vessel. The port side list accelerates as thousands of tons of seawater displace the air inside the hull. The center of gravity shifts irrevocably. The ship begins to roll over. This rotation triggers a mechanical event that few naval engineers ever witness. The Bismarck carries a main battery of 8 15-inch guns housed in 4 massive armored turrets. These rotating steel fortresses are designated Anton, Bruno, Caesar, and Dora. They are not bolted to the ship. They sit on circular roller paths held in place solely by their own immense weight. As long as the ship remains upright, gravity keeps them seated in their barbettes. But the ocean does not negotiate with geometry. As the battleship capsizes past the 90-degree mark, gravity reverses its allegiance. The friction of the roller paths is overcome by the mass of the guns. One by one, the 4 turrets slide out of their mountings. They disconnect from the hull and begin a free fall toward the seafloor 3 miles below. The ship is now upside down. It sheds its primary offensive weapons before it even leaves the surface. The hull is no longer a warship. It is a heavy hydrodynamic shape accelerating into the deep. The descent creates new and violent forces. The inverted hull acts like a hydrofoil diving at a steep angle. It accelerates into the deep, fast enough to start tearing itself apart. The water resistance tearing at the structure is immense. The stern section is not designed to withstand this drag. The structural steel reaches its yield point. Somewhere in the fall, the stern section tears away from the hull. The stern snaps off. It tumbles away into the darkness, leaving the main hull to continue its plunge alone. This is the imperative of the forensic salvage. We know the ship was defeated on the surface, but we do not know what killed it. The British report claiming they sunk the ship with gunfire contradicts the German report claiming they scuttled the ship with valves. The truth is locked inside the armored citadel currently falling through the water column. To find the answer, we must follow the wreck down to the abyssal plain. We must examine the steel plates that survived the fire and the pressure. The evidence is waiting in the dark, but the environment is hostile. The Bismarck is heading for an impact that will register on seismographs, 15,700 feet. This number defines the boundary between the surface war and the forensic reality. It is not merely a vertical distance, it is a crushing force multiplier. At this depth, the Atlantic Ocean exerts a pressure of nearly 7,000 pounds per square inch. This is the regime of hydrostatic pressure. It is a relentless, omnidirectional force that seeks to exploit any differential between the interior and exterior of a submerged object. If the Bismarck were a sealed submarine or a watertight citadel maintaining 1 atmosphere of pressure inside the steel plates would buckle instantly. The hull would collapse inward with the violence of an implosion. But the battleship survives the descent because it has already failed. The hull is compromised. Water floods every compartment during the plunge to the seabed. As the internal spaces fill with seawater, the pressure inside the ship rises to match the pressure outside. This equalization saves the structure. The steel plating does not need to resist the weight of the ocean because the forces are balanced on both sides. The hull becomes a flooded artifact rather than a crushed vessel. This allows the armored citadel to arrive at the seabed largely intact despite the extreme depth. The arrival is violent. The ship does not settle gently into the mud. It strikes the bottom with the kinetic energy of a freight train. The impact point is not a flat plane, but the sloping flank of an ancient underwater volcano. It strikes with enormous kinetic energy. The collision triggers a massive submarine landslide. The battleship does not stop. It acts like a steel sled carving a trench through millions of years of accumulated sediment. The hull surfs down the mountainside, riding a wave of mud and debris. This event creates a distinct geological feature known as the slide scar. Sonar mapping reveals a deep gouge in the seabed, extending 5,000 feet from the initial point of impact. The ship skidded for nearly a mile before friction finally overcame momentum. The violence of this slide buried the hull up to the waterline in dense clay. The screws and the rudder are hidden. The lower belt is obscured. The ship finally comes to rest on a 14.5-degree slope, stable and upright. The upright orientation is a matter of hydrodynamics, not luck. When the 4 heavy turrets fell out near the surface, the center of gravity shifted dramatically. The ship became bottom-heavy. During the long fall, the hull naturally rotated back to an even keel, like a shuttlecock finding its aerodynamic equilibrium. By the time it hit the volcano, it was perfectly aligned. When Robert Ballard discovered the wreck in 1989, the first images revealed a ghost ship sitting proud on the bottom. The guns are gone. The swastikas on the deck are visible. But the most important data is hidden in the steel itself. The ship survived the fall. The question remains whether it survived the battle. The British fleet fired thousands of rounds. We need to know how many actually penetrated the armor. We are looking for holes in a fortress that was built to be unsinkable. The answer lies in the gray metal rising out of the darkness. 2,876 shells fired. 0 catastrophic magazine detonations. This mathematical discrepancy defines the central mystery of the wreck site. In almost every other engagement of the war, a battleship subjected to this volume of fire detonated. The heat and shock waves from incoming heavy artillery usually trigger a chain reaction in the propellant magazines that vaporizes the ship instantly. But the Bismarck did not explode. It burned, it listed, it sank. But it remained structurally one piece until the stern broke away during the fall. The forensic question is how a ship can absorb 400 confirmed hits and refuse to disintegrate. The answer lies in a specific quirk of German naval engineering known as the Turtleback armor scheme. Most battleships rely on a thick vertical wall of steel called the main belt to stop projectiles. The Bismarck uses a more complex geometry. The outer belt is 320 millimeters of hardened steel. This is formidable, but not impenetrable to the 15-inch guns of the British fleet. However, behind this vertical wall sits a second layer of armor sloped inward at an acute angle. This internal slope creates a mechanical deflection trap. When a British shell pierces the outer belt, it loses kinetic energy. It then strikes the sloped inner deck, not at a flat angle, but at a glancing angle. The physics here are identical to a stone skipping off the surface of a pond. The projectile is deflected upward into the superstructure rather than penetrating downward into the vital machinery spaces. This design accepts the destruction of the upper decks to preserve the buoyancy of the hull. The ship sacrifices its ability to fight in order to retain its ability to float. The remote-operated vehicle survey proves that this geometry functioned exactly as designed. The superstructure is a ruin. The funnel is riddled with holes. The bridge tower is detached and lying upside down in the silt. But the main armored citadel is defiant. We see the violence of the surface battle in isolated details. One specific artifact captures the precision of the British gunnery. A large optical rangefinder lies in the debris field. It has a clean circular hole punched directly through the metal housing. An 8-inch shell from the cruiser Dorsetshire or Norfolk passed straight through the instrument without detonating. It is a surgical wound in a chaotic battlefield. This level of destruction should have doomed the ship, but as the cameras pan down to the waterline, the damage stops. The hull plates are smooth. The torpedo bulkheads are straight. The forensic count of shell impacts reveals a startling conclusion. The British guns shredded the crew compartments and the fire control systems. They silenced the weapons and killed the command staff. But they failed to smash the watertight integrity of the lower hull. The engines were running, the magazines were dry. The ship was a burning scrap heap above the water, but it was still a watertight vessel below. This creates a logical problem. If the armor belt successfully deflected the incoming fire, the ship should have remained afloat indefinitely. A battleship does not sink because its radar is broken or its bridge is burned. It sinks because water enters the hull faster than pumps can remove it. If the British shells did not let the water in, then we must find the mechanism that did. The evidence suggests that the final fatal wound was not inflicted by the enemy. It was self-inflicted. 70 minutes. That was the approximate duration between the cessation of effective German fire and the final plunge. For the crew trapped inside the burning citadel, this was a period of calculated destruction. The guns were silent. The steering was jammed. The British battleships had closed to point-blank range, turning the engagement into an execution. In this window of time, the German command faced a binary choice. They could wait for the enemy torpedoes to crack the hull, or they could execute scuttling measure 5. This is the naval term for deliberate self-destruction. It is not an act of panic. It is a technical procedure designed to ensure the ship cannot be captured or salvaged. The mechanics of scuttling a 50,000-ton warship are not as simple as opening a door. The process involves the main circulating pumps and the condenser intakes. These are massive valves at the bottom of the hull, designed to suck in seawater for cooling the steam turbines. Under normal operations, they are the lungs of the propulsion system. To scuttle the ship, the engineers must uncouple the intakes and lock the valves in the open position. This converts the cooling system into a high-volume flood channel. The ocean rushes into the engine rooms not through a jagged hole in the armor, but through the ship's own plumbing. The forensic evidence for this decision is usually hidden deep inside the wreck, where no remote-operated vehicle can penetrate. However, the debris field offers a fragile piece of proof that supports the controlled sinking theory. In the hangar bay, amidst the devastation of the superstructure, sits a single Arado 196 float plane. This is a lightweight aircraft built of aluminum and fabric. It is soft. It is flammable. It is the antithesis of an armored battleship. Its survival is a logical paradox. If the British shells had penetrated the magazines, or if the torpedoes had triggered a catastrophic internal explosion, the shockwave alone would have atomized this aircraft. The hangar decks would be twisted scrap, but the Arado is intact. Its wings are attached. Its canopy frame is visible. Its presence confirms that the interior of the ship did not suffer a violent overpressure event. The magazines did not detonate. The citadel remained stable until the moment it slipped beneath the waves. This preservation of a fragile aluminum plane implies that the sinking was gradual and hydrologically controlled. A ship torn apart by magazine explosions sinks violently and quickly, often breaking into thousands of pieces. A ship that is scuttled fills progressively. It settles lower in the water, maintaining its structural cohesion until the reserve buoyancy is exhausted. The Arado tells us that the Bismarck did not die from a sudden heart attack. It died from a loss of blood. The timeline supports this. The British fired torpedoes at the stationary hulk, but the ship was already settling by the stern. The list to port was increasing. The scuttling charges fired in the cooling intakes accelerated a process that was already inevitable. But the crucial distinction remains. The British guns silenced the ship. They stripped it of its ability to fight, but they could not punch through the Turtleback armor to let the water in. The German engineers had to open the gates themselves. The final forensic task is to confirm this by looking at the only part of the ship that never lies. We must inspect the hull, plating itself for the fatal wounds that aren't there. The wreck shows remarkably few penetrations into the armored citadel at the waterline, and the most visible holes sit above it. This statistic represents a 99.5% failure rate for the British armor-piercing shells against the German vertical protection scheme. The forensic survey of the hull moves slowly along the starboard side. This was the windward side during the final battle, and the target of the heaviest concentration of fire from the battleships King George V and Rodney. The remote-operated vehicles glide past plate after plate of 320mm cemented steel. We see deep gouges. We see primitive impact craters where 1-ton shells smash themselves to pieces against the hardened face of the armor. But we do not see penetrations. This visual data narrows the dispute, but it doesn't end it. The British claim they sank the Bismarck with gunfire and torpedoes. The German survivors claim they scuttled the ship to prevent capture. The steel tells the truth. If the British gunfire had sunk the ship, the main belt would be riddled with Swiss cheese punctures, allowing the ocean to flood the machinery spaces instantly. Instead, the belt is a scarred but unbroken shield. The Turtleback geometry successfully deflected the kinetic energy of the 14-inch and 16-inch shells, protecting the buoyancy of the lower hull, even as the superstructure above was reduced to scrap. As the cameras rise from the armor belt to the teak, decking a stark symbol of the past emerges from the gloom. On the bow and stern decks, the gray wartime paint has eroded away after decades of exposure to the saline current. Underneath the paint, the original aerial recognition markings have been revealed. The black and white swastikas are clearly visible against the red background of the wood. They are pristine. They serve as a chilling reminder that this wreck is not a geological formation, but a suspended moment in political history. The ocean has stripped away the camouflage to reveal the true identity of the vessel. The investigation moves inward to the torpedo bulkheads. These are the internal walls designed to absorb the shock of underwater explosions. The British cruiser Dorsetshire fired 3 torpedoes into the hull at close range in the final minutes. If these torpedoes were the cause of sinking, the internal bulkheads would be buckled and torn. The survey reveals that the torpedo bulkheads are straight. They held. The structural deformation is minimal. Later surveys point to torpedo damage and impact forces as part of the story. But the Citadel still resists a clean, simple explanation. This leaves only one hydraulic path for the water that dragged the ship down. If it did not enter through the armor belt, and it did not enter through the torpedo defense system, it must have entered through the bottom. The scuttling valves. The forensic conclusion is absolute. The Bismarck was a mission kill. The British fire destroyed its guns, blinded its sensors, and silenced its command. The ship was a burning wreck incapable of fighting back, but it was not sinking. The engineering team made the decision to terminate the vessel. They opened the seacocks and allowed gravity to finish what the Royal Navy began. The ship was not conquered by steel, it was conquered by a decision. Dead but pristine, the ocean preserves what it destroys. This paradox defines the final resting place of the German battleship Bismarck. After more than 8 decades on the floor of the Atlantic, the wreck exhibits a level of preservation that defies the violence of its end. The guns are gone, the superstructure is shattered, but the fundamental geometry of the ship remains sharp and authoritative. It sits upright on the side of the volcano, looking less like a shipwreck and more like a surplus vessel parked in a dark hangar. The most striking element of this preservation is not the steel, but the wood. The decks of the Bismarck were lined with 50,000 square feet of Burmese teak. In shallow water, wood is food. It is consumed rapidly by teredo worms and other wood-boring organisms that recycle organic material into sediment. But at 15,700 feet, the biological rules change. The abyssal plain is a biological desert. The pressure and the lack of nutrients prevent the survival of wood-eating borers. As a result, the teak decking is virtually intact. It retains its fibrous texture and its yellow color. While the steel walls of the conning tower are rusting away, the wooden floorboards where the admiral stood remain solid. This contrast is driven by chemistry. The steel hull is subject to the slow, relentless process of galvanic corrosion. The Atlantic Ocean is an electrolyte. The ship is a massive battery. The different metals used in the construction, the high tensile steel of the hull, the bronze of the propellers, and the aluminum of the aircraft interact electrically with the salt water. This triggers an ion exchange that slowly converts the metal back into iron oxide. The ship is bleeding rust into the water. It is a slow-motion dissolution that will eventually reduce the 50,300-ton giant to a stain in the mud. But that timeline is measured in centuries. For now, the Bismarck serves a different function. It is a war grave. More than 2,000 men were aboard. Perhaps 800 to 1,000 reached the water. Only about 114 survived. The wreck is the tomb for the rest. The open hatches and the dark casemates are the final stations of a crew that obeyed their orders until the water took them. The forensic expedition respects this boundary. The remote-operated vehicles look, but they do not touch. There is no salvage of artifacts. There is no recovery of gold or souvenirs. The only thing recovered from this site is the truth. The objective of the forensic salvage was to adjudicate the dispute between the British Royal Navy and the German Kriegsmarine. The survey is complete. The verdict is clear. The British won the battle. Their gunnery was precise and overwhelming. They turned a combat asset into a burning hulk. But the German engineers won the technical argument. They designed a ship that could not be sunk by gunfire alone. It took the deliberate opening of the sea valves to break the buoyancy of the Citadel. The Bismarck remains on the seamount, a monument to the limits of armor and the absolute nature of the sea. It is a fortress that could defeat projectiles, but could not defeat physics. It will sit in the darkness for another 1,000 years, slowly shedding its armor plates one by one, until the ocean finally reclaims the iron it allowed the engineers to borrow.